Hi, everybody. It's Mr. Steger. I'd like to talk about thermal energy and heat here. What's the difference between temperature and heat? We're going to learn about that. What is thermal energy? Thermal energy is essentially the total kinetic energy of all the particles or molecules or atoms in something. Temperature is not energy. It's a measure of the average kinetic energy of all the particles in something. So when you're taking the temperature of water, a glass of water, what you're getting is the average kinetic energy of that glass of water. And the example I've got here on the right-hand side, the glass of water and the lake are both at 52 degrees. That's the average kinetic energy of all the water particles in both of those areas. The lake, though, obviously has more molecules of something, so it has more thermal energy. Equal amounts, if one substance has a higher temperature, it has a higher thermal energy. So temperature differences in thermal energy, like I mentioned before, temperature is the average kinetic energy of the particles in something. Remember, kinetic means that those particles are all moving. More heat, more kinetic energy. In this instance, we've got two glasses with the same volume of water. One has a higher average kinetic energy or temperature than the other. That glass would have more thermal energy. Now, in our example here, keep in mind that heat is transferred from higher temperature objects to lower. Energy always flows from higher to lower, hot to cold. So an ice cube in water, the heat from the water is being transferred to the ice, causing it to melt. When you measure the temperature of that ice water, you're getting the average kinetic energy of both the melting ice and the water that was there originally. So in this example, we've got some bottles of soda in a pail of ice. Which way is the heat moving? If you answered from the bottles to the ice, you'd be correct. Adding or removing heat from an object affects its thermal energy, its temperature. When you put a cold pebble in your hand, the heat is transferring from your hand to the pebble. That's why the pebble feels cool to touch. When that pebble reaches your hand's temperature, you've reached equilibrium, it no longer feels cool. Conversely, if you put your hand on something warm, let's say the hood of a car that's been sitting out in the sunlight, it feels hot, and that's because the heat from the hood of the car in the sunlight is transferring heat to your hand. I've got a link to this video for you. I'm not going to play it here. It's about 4 minutes long. It's in the overview document that I've got with all 4 of our modules on it. It takes about 4 minutes, but it's kind of interesting to watch people and their misconceptions about temperature. Now, one of the things I want to remind you about is back when we looked at properties of matter, we noticed that things can be in either solid, liquid, or gas form. When you add heat energy to matter, you tend to cause those bonds to break or to move apart from each other. So it goes from solid to liquid to gas. If you remove heat from something, the reverse happens. We go from a gas condensing to a liquid, which then solidifies. So there are 3 ways that heat can transfer. The first is conduction. It's a very simple example that we've got here. When you touch, there's direct contact between the objects. The heat transfers very directly. The convection, a little bit more complicated. Convection occurs when things heat up and they become less dense. As things become less dense, they tend to rise. And as things cool, they tend to become more dense and sink. There's several examples that we can think of. I've got one here with a radiator. As that radiator heats up air, it rises. As that air transfers its heat from one molecule to another, it cools and then it returns. This happens in water as well. The last way is radiation. Waves can carry heat energy. They don't really need to pass through something like conduction do or convection do. Holding your hands up to a fire is an example of that. Another really good one is that the sun radiates heat energy towards us, which you can feel on a sunny day. Lastly, with all of this talk about transferring of heat from high to low, one of the things that, especially in Wisconsin and northern part of the United States, we're very aware of is insulators. Insulators are poor conductors of heat, and we may want to purposely use insulators, for instance, in our homes or in an insulated styrofoam cup to hold either hot or cold beverages. Insulators are simply things that slow heat transfer. Thanks for listening.